find the solutions, notice here's an S, of absolute value, that's what those bars mean, of 4y minus 15 equals to 13, all right? So again, we're going to find the solutions of the absolute value of 4y minus 15 in the bars equaling to 13. Let's take a look at this problem. See why I said, first of all, it's so important to know the word solutions. This one's going to have more than one answer. This is going to have more than one answer because there are two ways to make this a true statement, two ways to make this equation true on both sides. We need to get the absolute value inside here, the value you've got in here, 4y minus 15, we need to let it equal to 13, or it needs to equal out to negative 13. Because remember, with absolute value, it doesn't matter whether it's positive or negative inside the bars, the answer is going to come out positive once you're looking at absolute value. It's the distance from 0, and we measure distance always positively. So let's see what we've got going on here. We've got two equations, as I said, that are going to work for us. We've got 4y minus 15 equals 13. And you say, well, that's what we see. Exactly. That's one option. You get the positive 13. The other option you have is 4y minus 15 can give you the negative value of negative 13, all right? So we're going to look at two possibilities here. Now, if you look at these individual equations, they're very simple linears, right? I mean, it's just a matter of getting y by itself. You've just got to remember to start with a negative 13 and a positive 13. The positive, negative, or plus or minus sometimes we like to call it. But make sure they are two different equations. Let's work them out and see where we're going to go. We're going to add 15 over here. By the way, you never change 4y minus 15. You always leave it as it is. Do not be tempted to make that a positive 15 because it says absolute value. What's inside the bars stays as it is. It's the number outside that changes its signs. Don't forget that. Let's add 15. And you know what? We're going to have 4y. On the left, we're going to have, ooh, what is that going to add up to? It's going to give us 28 on the right, which I like because it goes in evenly, doesn't it? When we divide both sides by 4, good old division property of equality working your way there, we're going to have y equaling to 7. Now, I feel pretty confident it's going to work. Let's do a quick check. If we say 4 times 7, we're going to get 28, minus the 15 gives us positive 13, and the absolute value of 13 is just that, positive 13, all right? So let's check the other side of the story. We're going to add 15 just like we did before. We're going to be that plus 15. You're going to have 4y left by itself because remember, these go away. And this is going to leave you with, whoa, how about that? It's going to leave us with 2. Now, some of you get a little freaky out there and start to freak out when you say, oh, gosh, I got to divide 4 into 2. Well, it won't go. What do? Well, we divide both sides by 4. We use our division property of equality. And the 4's take a hike. They divide each other out. And over here, we've got a fraction that's developed. It's called 2 over 4. Hey, simply reduce it. Reduce it down. And it's going to be 2/4, which reduces to 1/2. Does 1/2 work? Let's find out. 4 times a half gives us 2. Subtract 15, we get a negative 13. And you know what? If we put a negative 13 back in here, the absolute value of negative 13 does equal positive 13. So it does check through. Both of them do. Great problem of the day, a little Algebra 1 to kick you into gear today, all right?
For more math help, visit TNLearn.org.